So today we're going into 1.7 at school, representing rules as functions and a graph. There should be, or graphs, an S at the end of there. All right. So a relation is a set of order pairs. Something very important to have in your notes, so make sure you're taking some. That a relation is a set of order pairs. The domain of an order pair is all the x values. So remember, a point, it's x comma y. That is a point. X comma y. So a domain is called, is the x value. So right here is the domain. So here is a set of points, and all the black numbers are the domain. And all the y values are the range. So domain, right here to have that down. Range. And if you want to put down these examples as well. So this is a relation, a set of points. Or ordered pairs. Let's be accurate. Ordered pairs. Oh, Miss Weir can't spell. Parentheses. And all the black numbers are domain, and all the blue up over here is range. All right, so we're going to be using that knowledge as we progress into this. So here's a couple more things that you just have to write down. Sorry for all the vocab, just we have to make sure that we understand this. So here's this little function machine, and we put the domain, or another word for domain. It's kind of like, you know how like some people have nicknames? Like for instance, my first name is Catherine, but I also go by Katie. I also go by Kate. My family calls me Kate. My friends sometimes call me Kat or Kay. You know, I have a lot of different names. The same thing goes with a point, X and Y. X can go by domain, and it can go by, as input. It's got a lot of nicknames. That's the word I'm looking for, nicknames. Y can go by range, and it can go by output. So here, this is the function machine, and we throw the X value into the function machine, or the input, and out comes the Y, or the output, or the range. So whatever we put into this machine, we get an output, which is pretty, I think, logical, right? If for every action, there's a cause, right? It's like a domino effect. You push the dominoes fall down. For everything you do, there's always an effect. So X is something that you're doing, an action. Y is the result of that action. So all of these inputs are first going to be put into our functions, and then we're going to be getting outputs. To make sure that a function is truly a function, this right here is a very important statement. It says a pairing of inputs with outputs such that each input is paired with exactly one output. So for every X, there is only one Y. So for every X value, there is a Y value. And I know right now you're like, oh my God, she's just talked about a function machine, and there's a lot of words going on here, and X has nicknames. You know, I understand it's a lot of information, but these examples coming up should break it down for you. Hopefully, if not, let us know. So here's our first example, just identifying domain and range. All right, sorry, my computer was acting up. I was trying to figure out why. The input and output table shows the cost of various amounts of regular unleaded gas, which is pretty accurate. I mean, Costco's price right now is $1.94, and the gas station on the corner near my house is $2.14. And this is saying it's $1.99. So that's, it's pretty average, I would say. So we have, let's finish reading the sentence. Identify the domain and range of the function. So your domain, remember, X, write down all the nicknames. X is called domain, and what else is it called? Input. Y is called range and output. So right here where it says input gallons, that's my X value. And right here where it says output dollars, that's my Y value. So which makes sense, for as many gallons as I'm putting into my car, my output, the amount of money I'm spending, is going to change. So if I put 2 gallons in my car, the price is going to be different than if I put 10 gallons in my car. So we just want to list all the domains and all the ranges. So all the domains are all of these numbers, 10, 12, 13, and 17. All the ranges are these numbers. $19.99, $23.99, $25.99, and $33.98. So depending on how many dollars I put, how many gallons I put in my car, the amount of money I'm spending is obviously going to change. So this is just identifying, just being able to say, hey, these numbers are a domain, these numbers are our range. That's all that question's asking. Now, I want you to try. Identify the domain and range of this function. So what is the domain? And what is the range? All these numbers right here are the domain, 0, 1, 2, and 4. And all of these numbers, Christmas colors going on, are the range, 5, 2, 2, and 1. All right, now for that slide that had a whole bunch of words on it, and I was talking about a function machine, this part, where you were probably like, what the heck is she talking about? Now here's an example talking about this, those words. Tell whether the pairing is a function. So in order to be a function, a true function, for every x value, there's only one y value. So let's look for every single x. So remember, input is x, output is y. For every single x, there's exactly one y. So let's look at the 10. For every x, there's one y. There's only one y, and it's a 5. Let's go to 5. For every x, there's one y. All right, in this case, it's a 4. For every x, there's one y. Well, wait a second. This x has 2 y's that it's going to, 0, 2 and 0, 3. Because this x appears twice and has 2 different y values, this right here, this table is not a function. And that's because the x appears twice. Or if you have something like this where there's arrows, your x is going to 2 different y values. Let's look at another example. This time there's no arrows, but I can see these are my x values, these are my y values. If I wrote them as points, this one is 0, 0. This one is 1, 2. If I wrote it as x, y. This one is 4, 8. And this one is 6, 12. Is this a function? Do you see any of the x values repeating themselves? No, I do not. I have a 0, I have a 1, I have a 4, and a 6. So is this a function? Yes, it's a function. It is. Bravo. Let's look at another example. So these are just showing you tables that are just kind of all placed a little bit differently. So remember, input means x, output means y. Here are my points. I have 3, 1, 6, 2, 9, 2, and 12, 1. Now here, 2 is repeating, right? Right here. Let's use a highlighter. Right here and right here. So 2 is repeating, but in order to be a function, x cannot be repeating. Y can be repeating. It's just x. X cannot appear more than once. So does x appear more than once in these sets of points? No, it does not. So is this a function? Yes, it's a function. The y can repeat. Let's write that one down. The y value, or its nickname, the output, can repeat. But x cannot. All right, is this function, is this pairing a true function? Yes or no? Remember, inputs x, outputs y. If I wrote these sets as a point, this is 2, 0. This is 2, 1. This is 4, 2. 7, 3. I can see in my table and when I wrote out my points, 2 appears twice. The 2 is in the x spot, so no, this is not a function. 2 appears twice. Is that how you spell appears? Or is it 1p? I don't know. Bad at spelling. All right, so remember, I was talking about nicknames. X, what are its nicknames so far that we know? We know its domain, and we know its input. Well, it's also called independent. I try to remember input, independent. And what are the Y nicknames? We have range, and we have output. We're also going to add to that nickname list dependent. Because the Y, whatever number it is totally dependent on whatever the X is. Kind of like you guys, you're dependent on your parents or your guardians because they're the ones who are putting a roof over your head and, feeding you your meals throughout the day. You're dependent on them. I'm dependent on myself. So I have no X and Y. There's only one variable here. But for you guys, your parents would be X and you would be Y. You're dependent totally. If they're making pasta for dinner, you're eating pasta for dinner. You're dependent on what they do. So that's what this function rules are talking about. It's really just a whole bunch of words to say, hey, we're giving X another nickname and Y another nickname. All right, example 3. Make a table for a function. The domain of function y equals 2x is 0, 2, 5, and 8. Make a table for the function, then identify its range, the range of the function. All right, so we got to make a table. Hold up. That's a lot of information. First, let's make it. Let's put it this way. Nice horizontal table. Well, just like all the other tables we were using before, we have an input, right? What are we inputting? And we're going to have an output, or an x and a y. It says the domain of the function is 0, 2, 5, 7, and 8. Domain. Is that going with input on that row? Or is it going with output on this row? It's going with the input, right? Because domain and input, they're just nicknames of each other. So I'm going to put all of those numbers, 0, 2, 5, 7, and 8, all in the same row as input, because input is just another nickname for domain. So output is totally dependent on input. What's going into this function? Well, 0 is, 2 is, 5 is, 7 is, and so is 8. Well, depending on what we get, all these numbers down here are going to be different. You're probably like, okay, well, now what? What am I plugging them into? Well, they gave me right here this function. And there's a variable in it, x and y. Well, I have a whole bunch of x values because remember, x means domain and it means input. Well, I'm going to input all of these numbers separately into wherever I see an x. And it's going to cause me to have an output, which is the value of y. So let's give it a shot. Y equals 2, and now I'm going to substitute x for 0, the first input, the first domain that they gave me. 2 times 0 is 0. So when I plug in 0, my output is 0. So right under this 0, I'm going to put my output as 0. Let's keep going. Y equals 2 times, well, now I'm going to input the next domain, which is 2. Y equals 2 times 2. Well, 2 times 2 is 4. So when my input is 2, my output is 4. All right, let's keep going. Y equals 2 times, now my input is the next number, which is 5, the next domain. 2 times 5 is 10. So when my input is 2, my output is 10. Almost done with the table. My new domain I'm plugging in is 7. So my new output is 14. And last but not least, my new domain I'm inputting is 8. I have 2 times 8, so my new output is 16. So I have all these input values, these domains, 0, 2, 5, 7, and 8, because that is what the question gave me. All I had to do was plug it in. I'm substituting in all these values for x in the equation that they gave me. So I made this table. Next, it says, then identify the range of the function. So what numbers are the range of this function? The range consists of 0, 4, 10, 14, and 16. All these values on the bottom in red. So this was a two-step problem. The first step was plugging and chugging. So I was plugging in all those domains and I was getting it out. I was getting in a range. And then the second was to just list the range. All right. So I'm going to give you a new one. We're going to skip this one. Example 4. I don't like that one. So here's a list of domains. And you're going to create a table for the function y equals x plus 6. Then list the ranges. So I'll help you out. The first thing I want to do is obviously create the table. Mine's just horizontal. Yours can be vertical. Doesn't really matter. I'm going to put my inputs and my output. Oops. So all of my inputs are my domains. So I have a 2, a 3, a 4, and a 5. Now I need you, list domains. That's what we just did, step 2. Now I need 3. Step 3, I need you to find the outputs. So that is what you are going to do, and you are also going to list the range. So in the box provided, go ahead and do that.